So we've had a few requests for an explanation on the homework for this week, assignment 4. So I thought I'd walk through and just maybe talk through the questions, see if it helps with how you visualize these problems in your mind and how you enter them in your calculator. So for question number 1, the key with this is recognizing that the question is asking you for the monthly payment, which is the clue that you're going to be dealing with the conversion of rate and periods so that we can get to the monthly payment amount. So what we're given is the fact that this is a $20,000 loan. Since it's money coming into our hands, that $20,000 is a positive. The future value of a loan that's going to be paid off after a certain period of time is going to be 0. The interest rate, which you got to use this chart over here to figure out, your score is 790. So it's a 5% annual rate, which means you've got to divide that by 12 to get to a monthly amount. And we know we want it to be monthly because we want the answer to come out on a monthly basis. And a 4-year loan, again, the periods, we've got to say, well, it's a monthly loan. So the number of loan payments over a 4-year period is going to be 48 because it's 4 times 12. So the answer is going to come out negative, as it should, because that will be money leaving your hands as you pay down this loan. So in question 2, it's asking, what is the total interest that you will pay over the life of this loan? You know that you borrowed $20,000, and you know that if you paid it back the next day, you would just pay him the 20 grand with no interest payments. But because you're stretching it out over a 48-month period at a 5% annual interest rate, or 5 divided by 12, we know that we're going to be making 48 payments times $460, 58.59 cents. If you multiply that out, you see that the total amount that you've repaid over the life of the loan is the $22,108.1232. So the difference between the $22,108 and the amount that you borrowed is the total amount of interest payments that you've made. In question 3, how much more would you have to pay a month if you missed a few payments on your credit card and your FICO score was reduced? So essentially all we're doing is problem 1, but replacing the rate. Instead of 5/12, it's 10/12, and we're still solving for the payment, which comes out to be higher. No shock. And then in question 4, how much more over the life of the loan did those missed payments cost you? Again, it's just doing the same math on the difference between the payments for the base loan versus the more expensive interest rate loan. And then for scenario 1, question 5, the 30-year home mortgage of $225,000 at an annual interest rate of 3.3%, we're again converting to a monthly payment. So anytime we're doing these conversions, whether it's monthly, semi-annual, quarterly, you don't have to change a thing with the present value or future value. It doesn't require you to twist your brain for that. Where you really have to be thoughtful is making sure we're doing an apples to apples when we're working with the rate and the periods. We're solving here for payment. And again, it's a monthly payment. And so we've got to convert his 30-year loan to 30 years times 12 months worth of payments in each year. Should be 360 if my memory serves. And you also need to convert that interest rate from an annual rate of 3.3 to a monthly rate of 3.3 divided by 12. And you solve for payment, which again should be negative because the payment is leaving your hands. The loan value up front is positive because it's money coming to you. So what will his total payments be for his mortgage? Again, we're just multiplying out his total monthly payment times the number of payments that he makes to arrive at the $354,000 and some change. And you can then see what did he pay for interest over the life of the loan. It's just the difference between his total payments and what his original loan principal was. In question 7, he's got a $20,000 car loan. So again, it's a loan. So it's a positive present value because it's money that came to him so that he could go ahead and buy this car. And it's a 3-year loan, but I bet it's going to be monthly with an annual interest rate of 1.6%. Wants to know what his monthly car payments are. So again, we are converting this 3-year period to the actual number of payments that he will be making. So it's 3 years times 12 months. And his interest rate, we have to convert from an annual rate to a monthly rate. So we divide it by 12. And when we solve for the payment, it's a negative number. And again, just to reinforce, when we're dealing with loans, unless it tells you there's going to be a balloon payment at the end, which I don't think we've ever given you that problem, you're going to be entering 0 for the future value. And then the payment amount, any loan payments are going to be negative because it's money leaving your hands. So what will his total payments be for his $20,000 car loan? Well, it's simply just taking his monthly payment of $569.37 times the 36 monthly payments to arrive at his total, $20,497.17. So if you want to figure out what his interest payments were, you just subtract the original principal from that amount. So scenario 2, you're supposed to use the UW Credit Union website, although you could also use your calculator. And assume you have a credit card with a balance of $5,280 that you want to pay off in 3 years, 36 months. The interest rate is 9.9%, which is an annual rate. So what's the monthly amount needed to pay off his credit card? So if he wants to pay it off in 36 months, and we're not going to add any additional purchases to it, and there's no annual fee, we're simply solving for the payment amount again. So you can use the UW Credit Union calculator to answer that, or you can use your own calculator. What if you could only pay $135 a month on this card? Approximately how many months would it take to pay the loan off then? And in this case, using the UW Credit Union site, it comes to 47.5 months. But again, you could enter in, you're going to be solving for number of periods, and your present value will be a positive $5,280. Future value will be 0. The interest rate will be 9.9% divided by 12. Your payment will be $135, negative $135. And you will compute for the number of periods. That's how you'd use your calculator to do it. And then for number 11, if you anticipate spending another $100 per month on this card, how long will it take to pay off? Well, here's a trick. You can use your calculator, and that same problem where we were calculating how long it was going to take to pay it off with a $135 monthly payment. Well, if we're going to be adding $100 per month to that card, well, you could just swap out and say, well, his net payment then, so if he's buying $100, but he's also sending $135 a month to make the payment, his net payment then on a monthly basis is going to be $35. And if you enter in a positive $5,280 for the current credit card balance, future value of 0, interest rate of 9.9% divided by 12, a payment of $35 a month, negative $35, and then compute for the number of months to pay it off, it's going to come back as an error because you will never pay off the credit card. That's supposed to be the takeaway from this section, which is interest rate will crush you if you don't keep on top of it. So in this case, he's going to drown in debt. And then for scenario 3, assume you go to buy a $23,000 car and are offered these 2 deals. Which one is the better deal? And I like using the calculator to solve these because I really think it makes it more clear, but you can use the UW Credit Union site to come to the same conclusions a little bit more quickly. So the monthly payment for the cashback offer using the UW site is $422.73. And the monthly payment for the other lower rate offer is $441.87. And so you can figure out which one is the better deal by just looking at your total payments that you make over the life of the loan and then comparing them. And it turns out that the cashback offer is a better deal by about $918.72. All right, so we're back. And by the way, you're not going to see anything on the test where I send you to another site to use a calculator. We want you to learn to use the one that you have. So scenario 4, using your calculator, we're looking at mortgages this time, and we're just comparing the difference, the impact of two mortgages where you're borrowing the same amount but experiencing a different interest rate. And we still have the situation where you have to convert the 30-year mortgage to the actual number of payments. So over a 30-year period, times 12 months per year, you're going to have 360 payments total in each of these mortgages. And in both of the situations, we're solving for payment, which will come out to be a negative number, but let's go back to the other stuff. The present value, since you're putting 20% down, is going to be 80% of $350,000 for both mortgages. Positive, since the money's coming to you. Future value, always negative because we want to have this loan paid off at the end of the term. The interest rate, you're going to take the full year rate divided by 12. We already talked about the periods, and we're computing for payment. And when you look at the difference in interest over the life of the loan, you're simply multiplying out the total payment times the number of periods, 360, and then subtracting the original principal. So in this case, the net interest over the life of the loan for Terrence was $292,331.60. And then for Bradley, same approach to the math, but his answer is slightly lower because his interest rate was lower. And in fact, over the life of the loan, the difference in payments between the two of them is $46,512. And then some ideas for how Terrence could lower his interest rate is all about how you improve your credit. So if you have any questions about this, send me an email or message me on Canvas.